All right, on the homework worksheet, the first page we had to classify real numbers. Now on your graphic organizer, you had all of those in a Venn diagram to show you which ones were related and some examples. We were talking about real numbers, and on your graphic organizers, you should have had that real numbers are all of the numbers that we're used to working with. So -6 is a real number. Okay, -6 is a real number. Now, the biggest decision that you needed to be able to make was, is it rational or is it irrational? Rational numbers are terminating or repeating decimals that can be written as fractions, and irrational numbers are non-terminating, non-repeating decimals that cannot be written as fractions. When you look at -6, you should know immediately that I can write that as a fraction, which makes it rational. Within the rational heading, you could have broken that down even farther. Integers are whole numbers with no decimals. So since this doesn't have a decimal, it is an integer. Okay, integers are all the positive, and negative whole numbers, including 0. Now, when you move into the whole numbers category, there's requirements there. Those numbers are positive whole numbers and 0. Negative numbers are not included. Same thing with natural numbers. These are your counting numbers, and negative numbers are not included. So on the first one, you should have had it as an integer, a rational number, and a real number. +2. We know it's a real number because that's all of the numbers we work with. It is rational because we can write it as a fraction. It is an integer because it does not have a decimal tacked onto it. It's a whole number. Okay. It is a whole number because it is not negative, and it's a whole number. And it is natural because it is a counting number. When we count using 2. So that one was everything but irrational. 0 is a real number. It can be written as a fraction, so it is rational. It is an integer because there is no decimal. It is also a whole number. It is not a natural number. Okay, it is not included in the natural numbers. Those start at 1. Two-fifths. 2/5. We know it is a real number because we're used to seeing it. Now, it's written as a fraction, which by definition makes it rational. If you wanted to know what the decimal is, you would divide that out, and you would have had 2 divided by 5. Which is 0.4. I should have knew that off the top of my head. Now, since it becomes a decimal when you divide that out, it is not an integer, whole number, or natural number. 0.222 repeating. Notice it's got the little dots telling you that that pattern continues on forever. It is a real number. The decision is rational or irrational. Because it is repeating, because the pattern repeats, we get to call that rational. Now, repeating decimals can be written as a fraction, which makes it rational. Okay, it is not an integer because it is a decimal. Sorry. It is also not a whole number, and it is not a natural number. The square root of 3 is a real number. It is not a perfect square. And if you plugged it into a calculator, you would get this. There is no pattern, there is no repeating, and you have no idea where to stop writing those numbers, which tells you that it is irrational. Okay, that is an irrational number. Okay, if it's irrational, it can't be any of those other ones. 15 over 3. It is a real number. It is also written as a fraction, which makes it rational. Now, to decide if it's an integer, we're going to need to simplify, and if we divide 15 by 3, we get 5. Positive 5 is an integer, no decimal. It is a whole number because it is not negative, and it is a natural number because we count with it. Negative 12 over 6. It is a real number. It is a fraction, which makes it rational. We have to simplify to see if it goes further. Negative 12 divided by 6 is negative 2. It does not have a decimal, which makes it an integer, but it is negative, which means it cannot be a whole number or a natural number. It stops there at integer. The negative square root of 4. It is still a real number because we can deal with the negative square root of 4. We could write it as a fraction, which makes it rational. Square root of 4 is a perfect square as well, so we know that that square root is going to factor out. And, of course, the square root of 4 is 2, making our solution negative 2. Negative 2 is an integer because it has no decimal, but because it is negative, it cannot be a whole number or a natural number. Will you turn those two lights out so we can see this better? All right, number 1 on the back. 4 students were reading the same science fiction book. Cindy has read 40% of the book, Mitchell has read 3/4 of the book, and Jennifer has read 2/3 of the book. And Carrie has read 0.625 of the book, which shows the amounts of the science fiction book that the students have read in order from least to greatest. That means they want these in order from the smallest number to the largest number. The first thing you need to do when you are asked to order numbers is to put them in the same format. Make them all a decimal, or make them all a fraction, or make them all a percentage. But they need to be in the same format in order to compare those. So 40% as a decimal is 0.40. 3/4, when you divide 3 by 4, you get 0.75. 2/3 is 0.66 repeating. And then the last one is already a decimal. It's 0.625. Now, we want these in order from smallest to largest, okay, least to greatest. The least number up there is that 40%. That eliminates A and C. Okay, that narrows us down to B and D. The next smallest number, it would have to be between 0.66 repeating and 0.625. 0.625 is the smaller of the two, giving us D for the correct answer. And notice how the answers are in original form. Okay, we convert them to match just so we can put them in order. The answer still has to be in original form. Anybody have a question on that one? All right, number 2. Which number line below shows the numbers from least to greatest? They've given you a number line. We've got some fractions, decimals, and percentages. We're going to need those in the same format to make sure that they're correct. If you know much about your fractions, you know that 1/4 is smaller than 1/3. But 1/4 is 0.25. 1/3 is 0.33. And then you've got 0.75, and 49% would be 0.49. Are these two in the correct order? They are not, because 0.49 should be smaller than that 0.75. So A is not correct. If you look at B, we've got 1/3 smaller than 1/4. That is not correct. We just said that 1/3 was 0.33 and 1/4 was 0.25, so it is not B. Looks like C is correct. It goes 0.25, 0.33, 0.49, and 0.75. So your answer should have been C on number 2. Number 3, they've given us some mixed numbers. They want them put in order from least to greatest. The first thing I notice when I look at these is that 2 of these numbers are negative. I have a negative 2 3/5, and I have a negative 2 8/9. When I look at my answer choices, the negative numbers have to come first because the negative numbers are smaller. That narrows me down to A and D. Okay, B and C have the positive numbers first, which cannot be correct. So we can get rid of those completely. Now we just have to decide which ones are in the correct order. 2, let's see, negative 2 3/5 would be negative 10, negative 13 over 5. And then we would have negative 18, 26 over 9, 2, 4, 5 halves, and 2 4/7 would be 18 sevenths. Now, if you're trying to compare these as fractions, you're going to need to compare those with the same denominator. You are better off just to divide those out. 18 divided by 7 is 2.57. That was the 2 4/7. The negative 2 3/5 would be negative 2.6. Negative 2 8/9. Negative 2.89. We'll round it to 2.9. And then 2 1/2 would be 2.5. Now, the negative numbers are negative 2.9 and negative 2.6. The smaller of the two is the negative 2.6. Okay, we have to be really careful with negative numbers because 2.9 is larger than 2.6, but because it's negative, that kind of works the opposite way. Negative 2.9 is smaller, giving us the negative 2 8/9 as the first number. And then the negative 2 3/5 would be the second number. And then we're deciding between 2 1/2 and 2 4/7. 2 4/7 came out to 2.57, and then of course 2 1/2 was 2.5. 2.5 is smaller, so your answer here should have been A. Okay, if you don't have enough room to work on your handout, it's okay to do it on separate paper. Just staple it to it where I can see it. Every year from 1981 to 1984, the temperature in Borger, Texas was recorded at 12:01 a.m. on January 1st, which is a list of these temperatures in order from warmest to coldest. Okay, they want the warmest temperature to the coldest. You want 1.31 to come first. That eliminates A and C. The coldest temperature would be the biggest negative, which would have been that 4.97. So your answer here should have been B.